Good morning and good evening to those all around the world. Thank you so much for joining our webinar this morning. Um, Today, we're going to walk through some of the agenda items. So, we're going to start with a short introduction here. The basic premise of this webinar is to describe how to protect our smart home in 2020. First, we're going to walk through an overview of what smart homes look like today with Alan Dixon from NKN. And next, we're going to walk through the smart home of tomorrow, what the future technologies that are being born today and how they will fit into the smart home of tomorrow, presented by me, Larry Peng from IoTeX. And then we have a very special presentation by Brittany Kaiser, co-founder of the Own Your Data Foundation, and famously the Cambridge Analytica whistleblower. She's going to teach us about why it's important for all of us to own our data going forward. And finally, at the end, we're going to answer any of the questions you have. So throughout the presentation, if you have any questions, please just let us know using the Q&A feature in Zoom. You should see it in the command center here. Yeah, any questions you have at all, just drop the questions and we'll be sure to address them. But before we get started, we're going to give a short introduction from the hosts, IoTeX and NKN. So IoTeX is building the Internet of Trusted Things. It's an open ecosystem where all people, humans, machines, and businesses can interact with full trust and privacy. Basically, we're a technology platform that tries to enable trusted data and trusted devices to facilitate a future Internet of Trusted Things. To date, we have a couple products. One is UCam. It's a fully private home security camera that lets users own their data. And we won the CES 2020 Innovation Award. We also have other types of products such as Pebble Tracker, which is a trusted environment tracking device. So, IoTeX is working on a number of different initiatives, all focused on trusted data and trusted devices. I'm going to let Alan give a short introduction of NKN.
Great, thanks, Larry. So NKN stands for a new kind of network. And what we're really trying to do is we're building the world's largest globally shared communications network. So we are an overlay network that sits on top of the existing infrastructure. And we've created some very interesting solutions on top of that, some services, one of which is our content delivery network platform. In fact, just yesterday, we announced to the world how we've actually been collaborating and working with iQIYI, which is kind of like the YouTube of China with over 100 million subscribers. So we actually deliver content for iQIYI. Also, one of our other services is DataRide. It's our kind of platform as a service for fast, reliable, secure, and low-cost messaging and file transfer. And with DataRide, we actually have secure remote access. And that's something that for the IoT community here might be kind of interesting to take a look at. Because what we can do is we actually allow secure remote access to your connected devices that are out there anywhere in the world. In fact, we have a solution that works really, really well with Mozilla's WebThings IoT Gateway. So if you follow the link down there, you'll actually find some description and also some information about how you can enable that for your own WebThings IoT Gateway from Mozilla. With that, I'll get back to Larry.
Thanks so much for the intro, Alan. And we're just going to get started. So Alan's going to again take us through some of the fundamentals of what a smart home today looks like. Basically explaining some fundamentals about Internet of Things devices, connectivity, and how it all fits together. So Alan, please take it away.
Thank you. So it's probably no surprise that the number of connected devices has grown to nearly 20 billion today. Many of these devices, such as smart speakers, security cameras, and connected light bulbs, are installed among the more than 40 million smart homes to help make your life safer, more convenient, and actually more enjoyable. However, these devices also hold sensitive information, which makes it important to keep your smart home secure, protected, and your data private. What I'd like to do though is, if you kind of take a look at look at these devices today, they're available in nearly every aspect of your home. So from the security of being able to monitor your front door with a smart doorbell from Ring, or managing entry with a smart door lock from August, or climate controls with thermostats and other devices. There are more devices than ever that can help you manage your life at home. So However, these devices also have a very similar makeup. And so let's take a closer look at that. So if you go to the next slide. Okay, IoT devices connect uh, connect the physical world to the digital world. So for example, a smart door lock will allow you to physically unlock a door remotely, given the right digital permissions. So these devices are basically purpose-built mini computers with their own compute, storage, and networking. And they all of them have some sort of sensor mechanism on there that actually helps them connect that real world to, or that physical world to the digital world, whether it be thermostats for being able to determine the temperature in your house, to light sensors and other types of devices that let it be very automated or allow you to get data from them that can be shared or used in some way. Because these are purpose-built computers, they are also subject to many of the same hardware software vulnerabilities that your laptop, phone, or tablet may have. So if you go to the next slide. So these devices also collect and share data. So if we take a look at the data life cycle of a typical device, the data is first acquired by a sensor, which records the information. For instance, a smart thermostat may take a temperature measurement every minute in your house. But some of this data may be processed on the device itself or sent to the cloud for processing and storage. The decision to where to process the data has a lot to do with the device performance, both in terms of battery life and processing power. So if data is sent to the cloud, the wireless module transmits that data to a nearby hub or gateway, which is then forwarded to the cloud application for processing. Now, for temperature data, that may not be all that important, but what if it were personally identifiable data? For example, the smart doorbell I mentioned before will also use camera sensors to detect movement and record visitors to your home, or even when you enter or leave the house. So it's important to keep that information safe. It's important to understand, and it's also important to understand where your data is being stored or transmitted to protect it, whether it's on the device itself, whether it's in an edge location, or whether it's in the cloud. So when that data is actually communicated or shared up to the network, you need to have a home network that actually supports that communication and connection. So if you go to the next slide. Okay. So to connect these devices, you need a home network that supports it. Because many of today's IoT devices have complementary cloud applications that need access to your device for management, data storage, or more, you need to have an internet connection. So the internet connection in your home, this is typically how a home network is set up. In fact, the IoT, the smart home IoT was actually kind of an augmentation of the existing internet infrastructure that you probably already have in your home today. So many of these today's IoT devices have complementary cloud applications. And so the internet connection in your home is terminated at the modem, okay? So, and for convenience, that modem is often connected to a Wi-Fi router or access point to provide wireless access to the devices in your home. So in order to support low power IoT devices, which are those that use protocols like Z-Wave or Zigbee, you'll probably find these in things like a smart door lock, for instance. You will need to add a smart hub to your network. This acts as a bridge between these devices and your home network. So it's important to note that the modem, Wi-Fi router, and the smart hub can often be combined into a single device. In fact, it usually is when you think about if you get the service from one of the internet service providers out there and they provide the hardware, a lot of times those will be all put into one type of box in your house just to make it more convenient for the user. If you go to the next slide. So one of the reasons why the smart home has introduced new protocols, you probably mentioned in the, as I mentioned in the last slide, Zigbee and Z-Wave, for instance. New protocol, these were added to allow wireless battery powered devices like door locks and smart detectors. So, so in other words, for devices that had to run on a battery for a long period of time that couldn't be connected to a wired power, we needed to have protocols that were much more efficient than, say, Wi-Fi is today. Typically in the house with Wi-Fi IoT devices, those would be ones that could actually be easily connected to a power supply or an electrical plug. So 3 of the most common low power protocols are Zigbee, Z-Wave, and Bluetooth or Bluetooth LE. So Zigbee, it's an open standard. It was developed by the Zigbee Alliance, which uses frequencies often that overlap with Wi-Fi, like 2.4 gigahertz as we show here. Z-Wave also is an open standard developed by a different organization called Silicon Labs, but it uses lower power than Zigbee, but it's also slower than Zigbee as well. So, which gives it a little bit more battery life for those devices. So, again, depending on how much, what kind of throughput you need, you may choose one or the other between a Zigbee or a Z-Wave type device. And then finally, Bluetooth or Bluetooth LE, which is a popular radio used in mobile devices, and I think that's one of the reasons why it's gained some fame more recently. However, the IoT device ecosystem is still developing on this. So if we go to the next slide, we'll talk a little bit more about, now that we kind of understand a little bit about how the home network is set up, so how the IoT devices are positioned, where data may be in your network in terms of whether it be on the IoT device itself, whether it be on an edge device, or even with the communications of that home network. Now we want to take a look at some of the vulnerabilities that those devices and networks can actually have. And so, it's interesting to talk about this today because, there actually been some pretty big exploits in this area that people need to kind of understand why these devices and networks were exploited. And what I'm going to do is provide you in the next slide some information on what you could do to help protect your home today. So smart home is vulnerable to malicious attack, both from the network and the device perspective. So let's start with the device side. So vulnerability exploits. So in 2018, for instance, this couple of years back, researchers found that 20 vulnerabilities in the Samsung's SmartThings hub. These were vulnerabilities that were in the software layer of those devices that allowed attackers to not only infiltrate or get into those that smart hub itself, but it was actually able to control smart locks, remotely monitor the home via connected cameras, and perform other, nefarious functions. Everything I talk about today, I will mention, have already been patched. So if you have a Samsung SmartThings hub today, this is not something that you need to worry about if you've updated your software. Let's take a look at malware, for instance. A lot of people have an Amazon Alexa device. So in late 2019, actually just last year, I should say, SR Labs research discovered that Amazon and even the Google smart speakers were vulnerable to eavesdropping via malicious third-party Alexa skills or Google Actions. These were applications or that could actually be installed on those devices to actually have more functionalities, right? So anyway, it's just interesting to see that was there. Since then, a lot of those have been patched, and a lot of those malicious software has actually been pulled for most marketplaces, both from Google and also from Amazon. If we go to the network side, there are a couple different kind of attacks that can happen. DOS and DDoS is one of them. DOS stands for denial of service. DDoS was actually distributed denial of service, typically associated with some sort of bots an army of different computers that actually attack a particular server. So in this one's a little bit older. So in 2016 and 2017, there was the Myra botnet, which actually infected a lot of Linux-based computers, but it also it took advantage of even some of the stripped down, unpatched Linux-based IoT devices. And what it would do is it would scan for open ports. It would look for, once it got to the open ports, it would try to look for default usernames and passwords to gain access to those devices and actually help it create that kind of botnet army that could be used for DDoS attacks. And then man-in-the-middle attacks. This is another kind of network attack that can happen. So in 2017, researchers discovered a remote exploit in the Zigbee wireless protocol. You notice that was one of the low power protocols we talked about earlier. And it compromised the Hue light bulbs. This is a very popular smart connected light bulb that's out there, paving the way for network attacks. So what it would do is it was able to get some of the authentication information from the Hue light bulb, actually infiltrate that, and through that light bulb was able to get to the home router or hub that was in your home to get more access to more devices within your house. And then finally, kind of one that really kind of connects both the network world and the device world is really eavesdropping and information theft. So one of the, actually just last year, there was a protocol called iLink P2P that enabled security camera, or it was a vulnerability in iLink P2P actually, that enabled security cameras, baby monitors, doorbells, would allow remote workers to intercept user to device traffic and clear text. So this was information that was sent that wasn't even encrypted, or so it could easily grab a lot of information about it, including video streams and device credentials. So, since then, those devices, many of those devices have been taken off the market. So again, if you have some of these devices, most of the times, most of these, everything I've talked about today, I should say, has been patched at this point, so not something that you need to be concerned about. But there are certain things you can do to make your home safer in all of these different aspects. So if you go to the next slide. So I want to leave you today with 5 things that I think you can do easily do today to help protect your smart home. So the first thing is really to harden your home Wi-Fi router. So if you have a Wi-Fi router in your home, you need to make sure that you've enabled all the security features that are on it, including make sure that all the ports are closed and that all the that the device firewall is actually enabled and turned on. Some of these are actually not turned on by default, and so you just need to make sure that you've gone through and done kind of a security audit of your Wi-Fi router settings and make sure that you've enabled any security features that would, especially when you talk about open ports, that, you know, we've talked about vulnerabilities there, as well as enabling that firewall. Second thing is, you want to, one of the things you can do, you can separate your home devices from your regular home network. So if you have a guest Wi-Fi network available on your Wi-Fi router, for instance, you can actually create kind of a separate kind of network that actually just your IoT devices are on. So in other words, even if your IoT devices may be compromised, or maybe your home Wi-Fi, the home network itself devices might be compromised, you're actually kind of separating yourself from those two. And so that can actually be another layer of security in the fight to keep your home secure. The third is really change all of those factory usernames and passwords. I can't stress this enough, how vulnerable you can be if you're using the default factory password, because that's going to be the first thing that a malicious piece of software or a person may try to get access to your network. Finally, update all your firmware and software regularly. All the things I mentioned here have already been patched, but you want to make sure that even things you haven't heard of have been patched. So if there is a security update, please make sure to upgrade your firmware and software regularly. And finally, review the device settings for privacy and data sharing. And this includes all the devices in your home, not just the Wi-Fi router. So if there is additional security, two-factor authentication, things like that, that your devices in your home have available to you, you should enable them to kind of get the best protection out there for your smart home. All right, and with that, I will hand this back over to Larry.
Great, thank you so much for that, Alan. If anyone has any questions on the smart home of today, feel free to ask in the Q&A and we'll address all these questions at the end. But I'm going to move on now to sharing more about what the smart home of tomorrow looks like, right? Given all these new risks that we are constantly being exposed to, even within our homes, what kind of technologies can really facilitate a safer future? So if we go back quickly to this diagram that Alan shared, smart homes today are consisting of multiple types of devices, right? Ones that kind of connect various types of edge devices, these modems, these routers, these smart hubs, ultimately maybe even just one device in the future that has capabilities to support Wi-Fi, Bluetooth, Z-Wave, Zigbee, and other wireless protocols. But what's important to realize is the devices that are connected to these routers and smart hubs may even come from different manufacturers. And this is something really important to consider. So if we look at kind of what the IoT device ecosystem of today looks like, it's extremely siloed, right? Just working from the top down here, you have different types of manufacturers that are building different types of devices. For example, August is a smart lock manufacturer. Google is a very famous thermostat manufacturer with their Nest products, and Amazon Ring, most famous for their doorbell cameras, but also now creating other types of devices such as window sensors, door sensors, and all these types of devices. Today, the interesting thing is the corporations that manufacture these devices are also the data owners. So each of them have kind of these individual silos of technologies and kind of vertically integrated tech stacks. So it starts all the way from the bottom with the devices themselves, which connect to gateways, which connect to the cloud, and then finally passing all of that data to different applications. The types of data that an August lock would need to recognize is obviously your credentials to unlock the door, even when that door was opened, as Alan was mentioning, a lot of very sensitive details that could be exposed just by simple metadata and data from these devices. Same thing goes with Google Nest and Ring, right? Specifically for these large tech giants, they have a very big desire to own our data. A lot of the things that we're used to seeing from Google and Amazon and other tech giants in the digital app sphere is starting to make its way into our homes now. So a lot of the surveillance activities, a lot of the data sales, now we're starting to get into this unprecedented territory where a lot of the data in our homes is extra rich, right? If a picture is worth 1,000 words, then a recorded conversation from an Alexa speaker or a recorded video from an Amazon Ring device is worth at least 1,000 keystrokes or even 1,000 pictures. So the richness, the sensitivity of that data is all getting more and more rich, which means these guys at the top here, the data owners of today, desire more and more of that data. The consequence of all of this is that a lot of these applications, clouds, gateways, devices are all non-interoperable, and there's a lot of competition for data. So we see these vertically integrated tech stacks kind of dominating today's IoT ecosystem. Quite literally, all these corporations are saying, you can't sit with us or you can't play with us. So what does the future look like? A future looks like a couple things, right? The first is that the non-interoperability and competition for data can be eliminated, right? We can create interoperable devices that use the same standards. We can use gateways that can talk to each other, clouds that can send data back and forth without very costly operations. And finally, applications that can finally share data with each other so we don't have to have a million apps on our smartphones. But perhaps the most important part of this future is that data ownership is not residing with the corporations anymore. It's going to be a more human-centered ecosystem where we can own our data and offer it to different applications on an opt-in basis, right? So next, I'm going to share some of the technologies that are really going to make this happen, right? So the first of which is blockchain. Blockchain is a controversial technology these days. A lot of hype from the ICO boom and kind of false promises have given a bad taste in many people's kind of mouths. But blockchain is really, when you think about it as a trusted foundation instead of a computation or storage platform, it comes with many important benefits. First of which is security. Blockchain is a distributed architecture, which means it's highly resilient to attacks. Second, it's interoperable. Instead of being vertically integrated like we've seen on the past slide, it's horizontally scalable. A third quality is, of course, is decentralized. This is an open and neutral infrastructure that anyone can access and anyone can build on. And finally, it's programmable. There's a concept of trusted automation via smart contracts. And finally, the last piece here is continuity. Because it's decentralized and distributed, it's basically a never down network with no single point of failure. So a lot of times, maybe you guys have some IoT devices from manufacturers that no longer exist. Those IoT devices are no longer serviceable because the tech stacks that they operate in have been taken down. But if we move these tech stacks to a decentralized blockchain, then they can live even past when the manufacturer has decided to shutter their doors. So, it's important to realize that blockchain is not the silver bullet that's going to solve everything. It's not the panacea, but it is a great foundation to layer on additional technologies that have built-in trust and privacy as a priority, which I'll describe in the following slides here. So one of the other technologies that's important to layer on top of blockchain is something called secure hardware, especially important when we talk about our smart homes today. Secure hardware is basically a special type of chip that's built into many types of devices today. The chip is called the Trusted Execution Environment. And on the right-hand side here, you can see this kind of technical diagram about what a trusted execution environment really does. It basically separates normal applications from applications that require full trust. So it's basically a secure world and a normal world that kind of pass data between each other, sharing different types of hardware platforms, but also isolating different software and hardware processes. Basically what this does is it guarantees the integrity and confidentiality of all data and processes executed within this special chip. This may sound like science fiction here around, the ability to utilize encrypted data without sacrificing our privacy. But the truth is that secure hardware is everywhere and you use it almost every day. The fact is, even the chips in our iPhones that manage our biometrics, for example, our fingerprints and our face IDs, the reason why we trust our phones to do that is because all this very, very sensitive information is processed within this kind of very secure, isolated hardware element. The chips on your credit card are also a form of secure hardware that protect the spending credentials. So, instead of having the swipe strip that was popular in the United States, just even up until a couple years ago, that thing had no kind of security built around it. But this chip kind of, this is a kind of the one and only chip that has those credentials, which can be revoked as well. So secure hardware also makes its way into our financial lives. And for those that are familiar with the crypto community, another piece of secure hardware is ledger devices. So similar to how credit card chips protect your spending credentials, ledgers will use secure hardware to protect your private keys. So all of these secure hardware devices and implementations are active today, but the thing is they're closed and proprietary. It doesn't allow us as users or us as developers to get into those trusted execution environments and run new processes within them. Basically, we want to be able to self-define what we deem to be very valuable as data and process that data within these secure hardware elements. So, an open and programmable and affordable secure hardware ecosystem is coming. Secure hardware is generated by the largest semiconductor companies in the world, such as ARM, AMD, Intel, and NXP. And the fact is, Moore's law, which kind of before stated devices get twice as fast every year, Moore's law has kind of hit a theoretical limit as far as performance, but we're seeing devices being twice as cheap every year. So you're going to start to see these more advanced and expensive chips make their way into more normal devices, including the ones in your smart home. And one piece of advice is, just like you read the nutrition facts for different types of foods that you put into your body, whether it's organic or GMO, you should also evaluate, what types of devices you're putting into your homes, whether they're secure or unsecure. So this is a little bit about secure hardware. The next enabling technology that's going to be important for our smart homes is something called decentralized identity. So decentralized identity is basically a way to issue identities not only to humans, but also to devices and to businesses to create interoperability and enable data ownership for individual people, individual devices, and individual businesses. today, if you think about the schematic of your smart home, a lot of these devices don't have identities, meaning they can't discover and be discovered by other devices, which means they're non-interoperable. And a lot of the issues with this non-interoperability in the IoT ecosystem today has to do with the lack of standardized identities and kind of connectivity standards, which we'll discuss in later slides. But just to walk through, a little history of what identity looks like in the digital world. The ones that we're very familiar with today are centralized identity, right? Register once and trusted by one entity. So this is basically any website that you've been on that asks you to create a new username and password. So the service provider will establish your identity and they'll maintain your identity. But the really important thing to note here is because the service provider created your identity, they also have the ability to take it away. So these are things like, for example, if you break the rules of Twitter, they can not only disable your account, but they can give your old handle to someone else, basically giving your identity away to another user. Another instance is called federated identity, where you register one identity and it's trusted by many entities. So service providers basically trust the identities established and maintained by other identity providers. So anytime you go to a website and it says log in with Google, log in with Facebook, etc., those are examples of federated identities. But very similar to centralized identities, these identities can also be taken away, right? If you think about all the websites you use your email address to log into, if you break the terms of Gmail, they have the right to take that email account away, basically taking your identity and even issuing it to other people. So what does the future look like? The future will look like something called decentralized identity, right? Register once and trusted globally by other individuals and other entities. So basically, this is a mechanism that's built on top of distributed ledgers where users kind of self-manage their own identity. So they create their identity, which means they're the sole owner of it, and they can modify it by adding credentials to it. They can add more information to it, and then they can offer that identity as a login to different services that they see, right? And the big difference here is because you're the one that created the information and the identity, you are the sole owner of it. When this concept makes its way into our smart homes, it's really important that we understand it's not just the identity of us that matters, but also the identity of our devices. So another big thing that's going to enable the future kind of interoperable and secure smart homes that we envision is IoT standardization. As Alan mentioned in his presentation, there's a lot of different wireless protocols out there. And as I just mentioned, there's a lot of different forms of identity that can be utilized. Just taking a look at this kind of diagram, these are all the different alliances and standards organizations that are working on various standards all the way from application layer to connectivity layer and from the B2C market to the B2B market. It's important that we define unified standards for hardware, identity, and connectivity. And that's going to be able to enable an open ecosystem, improve interoperability, and protect security and privacy. And this is very well encapsulated by this quote by ARM. Attempting to piecemeal disparate solutions that have different standards creates gaps in fragmentation, complexity, and security. So hackers see this and can expose these vulnerabilities, which is why a unified IoT ecosystem is truly essential. Luckily, there's a lot of great initiatives going on, such as Project Connected Home, Web Things from Mozilla, a lot of great work being done by the World Wide Web Consortium for Web of Things. World Wide Web Consortium is actually also the ones that are developing the Decentralized Identity standard. So as more of these efforts between industry leaders emerge, we're going to start to see more standardization of devices. But it's important for us to also push forward for standardization from a user perspective. Here's a little comic that we think summarizes the standardization ecosystem quite well. It's titled "How Standards Proliferate Across, AC chargers, character encodings, instant messaging." Standards are everywhere today, right? Even the shipping crates that you see at all the ports around the world, those are standardized crates that make one country's ports interoperable with another port. So that's just an example of a non-digital standard that is prevalent in the world today. So the situation here is there's 14 competing standards. it's ridiculous. We need to develop one universal standard that covers everyone's use cases. And now there are 15 competing standards. So, the goal here is not to create more unuseful standards, but to bridge the ones that, are prevalent and widely used in the industry to create more universal ways for devices, applications, cloud, and users to communicate more effectively. And the final one I want to talk about here is a concept called secure encrypted communications, right? This made its way into the news a lot lately with Zoom, right? Zoom was in the news because they made claims about their end-to-end encryption, but it turns out that it wasn't fully end-to-end encrypted. They actually had access to it. So what Zoom had mentioned that their technology could do, which was end-to-end encryption, was actually something called client-to-server encryption, which we describe here. So basically, if you have a mobile device that is powering your application and you have another device that you want to send data to, basically the way that a lot of applications work today is the communications between your mobile application will be encrypted up until it hits the cloud of the device manufacturer or service provider that offers you this service. And in the cloud, your data is decrypted and a lot of processes are run on top of it to basically deliver you services. But also, this is why Google and Amazon and all these tech giants are able to mine our data, establish digital profiles of us, and sell it to advertisers, which obviously is a hugely profitable business that doesn't really trickle down back to users. So having this, literally having this man in the middle is a source of a lot of smart home attacks today, just like the eavesdropping, the man in the middle attacks, and some of the other vulnerability exploits that Alan had mentioned previously. So, it's also worth noting that the most common types of attacks on our data are actually not from malicious hackers, but from malicious insider attackers. So these are kind of people like cloud admins. Recently Amazon just fired about 10 of their cloud admins because they were peeking into people's Ring video feeds, right? So even though, we're relatively protected from hackers due to this encryption, insider attacks are quite commonly the most common form of security threat, right? The truth is, a lot of the things that we do to try to patch up these problems today are done with regulations and with policies, right? GDPR in Europe and CCPA, California Consumer Privacy Act in California, are now emerging, but these things are very important to build transparency between how corporations use our data, but they surely don't guarantee our privacy. They operate more like operational frameworks that allow us to ask, what data do you have on me? Why do you use it? And also I can request to delete it. But you have to do this for every single company that holds your data. And usually this is for people that have a lot of time, a lot of resources, AKA not the vast majority of us. So one thing that we need to do is not only build, but also adopt technologies with true end-to-end encryption, which looks like this, right? So instead of having this server in the middle here kind of process your data, a lot of a big trend these days is that a lot of the computing will actually be done at the edge. It's called edge computing. So a lot of the processing of your data will be done either on a laptop, a mobile phone, even a security camera. So a lot of the things that were previously done in the cloud, we have the hardware today to do it on our devices locally, meaning we can eliminate insider attacks and breaches using end-to-end encryption, true end-to-end encryption. A lot of the technologies today, like end-to-end encryption and privacy and decentralization, it seems there's a lot of people that even have different definitions of these concepts. So it's important for all of us to understand what they really mean and make our own judgments about them. And just to wrap up this secure encrypted communication section, there's a lot of communications that happen from the device to our network, to the cloud, to our applications. Sometimes end-to-end encryption is also not enough, right? There's also this concept of hop-by-hop encryption. End-to-end encryption may be able to protect the content that we're distributing, but there's also metadata that can also be very telling about our activities. The concept about hop-by-hop encryption kind of also encrypts the metadata and kind of the data exhaust or data leakage that may emerge from these communications between these different hops. There's also technologies today where public keys are embedded into different devices so that we can do encryption without a certificate authority. And finally, a globally distributed and never down network can be a great foundation to power all these different secure encrypted communications. So, you know, I introduced a lot of new technologies just now. How does this all kind of, you know, fix the problems that Alan had shared previously? So when we put it all together, you know, we talked about several different types of smart home kind of vulnerabilities today, right? One of which is vulnerability exploits, where hackers gain control of your device. Malware is when they kind of, you know, install a fraudulent application on your device and, you know, and rip data from the device. Denial of service and distributed denial of service, man-in-the-middle attacks, and eavesdropping. So secure hardware is more at the device level, right? It does prevent vulnerability exploits because, you know, a lot of the important information is hardened within that secure element, and it definitely does protect against malware. Decentralized identity has a lot of different uses, right? A lot of man-in-the-middle attacks are due to the fact that unauthorized or unidentified parties can gain access. So having everything with an identity is a surefire way to understand who is accessing the data and whether they're authorized to do so. Regarding secure communications, you know, this has a lot to do with these man-in-the-middle attacks, eavesdropping, and denial of service. So basically, by creating secure channels that cannot be eavesdropped into or penetrated, we can really secure not only the content that we create at the secure hardware level and kind of tag it to an individual identity, but we can also protect the communications between different secure devices and between different identities. And finally, IoT standards, right? IoT standards actually probably has a foot in all of these different attacks, but by standardizing things, we can better understand the environment and landscape of risks and make appropriate decisions to standardize identity, hardware, connectivity, and many more things. And this is kind of what it looks like all together, right? We have a full view here, kind of the entire tech stack, where blockchain at the very bottom, you know, again, blockchain is a great tool to establish trust, right? Sometimes we throw challenges at blockchain that it's not really meant to solve, but blockchain is an amazing foundation of trust. The way I would describe it is, you know, if you're going to the grocery store, you probably don't want to take an armored vehicle. You just need a normal car, right? But if you're transporting very valuable goods or things that you deem to be sensitive and private, maybe that's where that armored car will come in. And that's what blockchain kind of plays a role in today. But blockchain will definitely be more instrumental in ensuring trust, not only for our smart homes, but for all processes worldwide very soon. So on top of this blockchain, we have gateways that will have built-in universal standards and kind of combine the modem, the router, and the hub all in one. So a lot of different connectivity mechanisms and a lot of different things all built into the gateways of the future, which will also have decentralized identity, so they can identify, discover, and be discovered, and also have built-in secure hardware to make sure no penetration happens at the gateway level. At the device level, we're also going to see decentralized identity and secure hardware. But what's really important is also a lot of the processing of devices will never make its way even to the gateway itself. These devices in the future, you know, will become more powerful, will become more connected. So a lot of the devices can actually just communicate peer-to-peer, back and forth, without needing to send larger data down to the gateways and down to the blockchain for processing. So not only is the computing layer going to be pushed more towards the edge, but also you're going to see a lot of secure peer-to-peer communications just between devices, encrypted communications and trusted communications, both horizontally across the tech stack and also vertically across the tech stack to ensure all of our data is nice and secure. So that's a little bit of a picture about, you know, the smart home of the future. Hope you guys enjoyed it. If you have any questions on anything I mentioned, feel free to drop it in the Q&A. But now we're going to move on to a guest presentation from the Own Your Data Foundation. I'm going to pass it over to Benjamin Leff, Head of Communications from Own Your Data Foundation. Unfortunately, I think Brittany is unable to make it today, but Ben can probably fill us in a little bit more on that. So Ben, I think you have the floor.
Thanks so much, Larry. And first of all, that was a fantastic presentation. Certainly learned a lot, and I'm wearing my tinfoil hat. And yes, you are correct. Brittany is setting up. We have our own virtual summit for the Own Your Data Foundation tomorrow, which you are all more than welcome to. It covers data privacy in times of crisis. So clearly, a situation like this. For those of you who aren't familiar with Brittany Kaiser, Brent, can we pull that slide up? There you are. She is the Cambridge Analytica whistleblower. She blew the whistle on, Cambridge Analytica and Facebook when they realized about all the data mining that was going on that we did not, as individuals, give consent to. And that is when Brittany kind of got thrown into the mix of things. She has become a thought leader and activist in data privacy, owning your own data, data rights, and something that we're very focused on, which is digital intelligence, digital literacy. We work with the DQ Institute, so much like your intelligence quotient, there is now digital intelligence, or DQ. As we move into this digital world, what we do today in our digital world has impacts on our real world lives and situations. So what we are working on at the Own Your Data Foundation is taking things such as digital identity, digital rights, digital literacy, communication, emotional intelligence, security, safety, and even digital use, and identifying kind of an all-embracing concept to help educate and empower not just adults, but more importantly, get this into schools and programs through our Own Your Data Foundation initiatives. And that is an introduction on Brittany and the Own Your Data Foundation and what we're about. And we really wanted to participate in this because the IoTeX, what you guys have been doing, not only brings together an understanding of how hardware and the Internet of Things are working right now, obviously, but in the future with device communication and things of that nature. And we're kind of working on the other side of the spectrum, which is we're working with legislators and along with thought leaders in the space to help make sure that these devices that are being built and these companies that are utilizing all this cloud framework are using it in a safe and informed manner to the community. So that is what the Own Your Data Foundation is about. And I appreciate you letting us give a little pitch up there. And thank you again for the IoTeX presentation. That was wonderful.
Yeah, thank you so much for that. Yeah, so just to add a few things about, sorry, a little echo here. But yeah, just to add a few things about owning your data today, right? A lot of us associate owning our data with financial return, but it's really more than just, receiving money for our data, right? The big thing about owning our data is at a systemic level, all of these smart speakers and security cameras and all these devices that are really being issued by Amazon and Google today are really threatening a lot of the civil liberties at the nationwide and also the international levels, right? It's not really just about whether Google and Amazon and Facebook have our data, but it's really about what they're going to do with it in the future, right? Today, our data is really used to create a lot of these digital profiles that are sold to advertisers. And today it's more of a nuisance, right? Or an annoyance that we see things in our Instagram feeds about things that we talk about, or, you have a conversation in your living room and then you see an advertisement in your Gmail or on your other social media platforms, right? Today it's creepy, but in the future, when the data that we give to these companies it's not just our browsing history or, things that we search in Google, but it's literally the conversations that we have in our homes and kind of the security camera footage that tells, when we leave our house every morning, right? A lot of this data is now can now be repurposed to really manipulate a lot of the actions that we take and kind of remove kind of the independent thinking that we have as a society. So that's a little bit more about why owning our data today is very important. But, and that's kind of the content that we have. So we wanted to, take the final minutes here to really walk through some of the questions that were asked. So, if you guys have any additional questions, feel free to use the Q&A feature in Zoom, and we'll get to these questions. But, the first question is from Benjamin from Own Your Data Foundation, who mentions, my home is completely loaded with Google products from every generation of their hardware, including speakers, alarms, cameras, thermostats, even the mesh network. So how do I best protect my home with this kind of setup? It's plainly obvious my conversations are being listened to due to targeted advertising, but I want to be able to control it. So yeah, this is a great question, Ben. Alan, I'll share some thoughts from my end, and then maybe you can jump in as well. But today, a lot of these Google devices obviously are listening to a lot of the things that we say, right? We're very familiar again with the surveillance kind of activities at the digital level. But, I think the best answer I would have regarding this is, simply to reevaluate whether the benefits of using some of these devices is worth it, right? I think personally, I used to have kind of like an Amazon Echo device, but even having it sitting on my table, there's like a camera there, and I would never be sure. There's no way for me to know, is this really, private, and does this device really work for me, right? So as we start to introduce new types of devices that do value privacy and security, that are built using these fundamentals of privacy by design and blockchain and secure hardware, those are the ones that are really going to enable this human-centered future. But in the meantime, there's a lot of advice that Alan gave regarding, hardening Wi-Fi routers and different types of things, actions that we can take today to better protect ourselves. But ultimately, the data is flowing up back to these tech giants. So we really have to take back control of our data to take back control as well. Alan, do you have some thoughts on Ben's question?
Actually, that was a pretty good response to that. I would add that, a lot of these products, especially the smart speakers, they're actually subsidized usually by Google or Amazon. And so they're actually assuming that you're going to share some information with them in terms of the purchases you're making and some of the information on there. So I think it's something to consider when you're purchasing those type of products. And I'm glad, Benjamin, you actually do understand that that information is being shared. You even see the advertisements from it. So I think that's kind of the first step. But as Larry mentioned too, I think you need to kind of make sure that you follow all the good procedures of turning on the security capabilities. Many of these devices do have additional security capabilities to it. So just make sure that whatever devices you're using, that you're enabling it to the best of its ability. And then in the future, if securing and making sure that your data is private is important to you, then you need to make purchasing decisions based on that. That may not be from one of these Google or Amazon or some of these other players too.
Absolutely. So the next question here is, something more about IoTeX and NKN is how far has the collaboration of IoTeX and NKN progressed since the last announcement? And are there any additional details about this? So, IoTeX and NKN, we're both based in Silicon Valley and very longtime friends in the blockchain and decentralized industry. And now we're starting to make our way into some real use cases and real products, right? So, NKN and IoTeX, we work on kind of different things, I would say. NKN is, as we mentioned, more focused. I'll let Alan kind of explain from his own words, but NKN is a globally shared communications network. So really doing a lot of the things around secure communications and content delivery in a trusted fashion, while IoTeX is more focused on some fundamentals of the platform level. So trying to enable application builders to use different tools to power different types of products and such. So basically, there's a lot of ways that we can work together simply just to build out these future tech stacks that we envision, right? There's a lot of connectivity at every step of this, and there's a lot of kind of data flow between applications and the need to power devices and applications on decentralized infrastructure. So, there's a lot of things that we're working on, obviously on the thought leadership side, but there's always opportunities to collaborate on more specific products here. Just in the interest of time, I'm going to move on to another question here from Gabriel. So this was a question originally for Brittany, but maybe either Ben or Alan, feel free to share your thoughts here. But the question here is, what software do you recommend to use for better privacy, more specifically around email and messaging, right? Qubes OS, Signal, Proton Mail, Telegram. I think from my perspective, it's important to just pick one that has true end-to-end encryption, right? Even WhatsApp, which is a Facebook product, has true end-to-end encryption, or at least so we think. But it's really important to think about those technologies like Telegram, Proton Mail, et cetera, that do have that true end-to-end encryption, which means there's nobody that's peeking into your conversations. Ben, Alan, any other thoughts on great privacy tools today?
Sure, Larry, from personal experience and professional as well. And I even saw on one of your slides, you accredited Wicker as one of the sources for a message, for an encrypted messaging system, which is actually a great point because Wicker, there you go, is explaining why they don't have this issue that affected Zoom. Wicker is a great privacy tool, Signal as well, and Proton Mail, which not only from a legal perspective because it's based in Switzerland, but because of all of the data privacy and encryption they've put into their software has made it an incredibly powerful tool for emailing. And it includes encryption and decryption within the email system. So it's all about, just like my question, Larry and Alan's answer to my question about how much do I want to utilize the convenience of the devices that I have versus the data that I give up. This is very much how much do you want to enhance your digital security using specific messaging systems, specific emailing systems, as well as encryption systems possibly, in order to protect the information that you are passing along.
Absolutely. Alan, any favorite privacy products of yours?
Yeah. So actually, we have a blog on this. So if you go to blog.nkn.org, you'll find an article about encrypted messaging, what it is, and why you should use it. So it actually goes through a lot of the different encrypted messaging apps that are out there. But I think the ones you talk about in terms of Signal and many of those other ones are actually great examples of good security tools that you could use.
Yeah, definitely drop that link to the blog in the chat so all of the folks can see. But that's a great question, Gabriel. You have a second question here around how do we choose what IoT devices to buy if almost all of them are storing data on the cloud and by tech giants, right? This is a tough question to answer. I think that just like we think about the evolution of disruptive technologies, right? We think about last year at the kind of the turn of the decade, I was thinking back around the 2010s, and it's just incredible to think that when 2010 came around, these services like Spotify and Uber and all these things didn't even exist, right? So just within the past decade, we've made a lot of cultural and societal change to ditch taxis and now use Uber, right? Which in the beginning was inconvenient, right? Because there's less of a network of drivers. Maybe the application, the user experience is a little poor. But eventually, as user experience catches up, the inconvenience obviously also catches up. Then you start to see these products be more adopted, right? I think we're just at the cusp of a big boom in individuals' recognition of privacy as a big issue, right? But the truth is, up until now, there really haven't been any alternatives. But now we're starting to see, not only at the messaging level, but also at the device level, a lot of devices out there that do have the fundamental premise of owning your data, which doesn't mean we cannot engage in the services and the types of things that we do normally, right? It just means we have the choice to keep our data private, to share it with others, to expose it to service providers, right? But without that choice, we're defaulted into this world where tech giants own our data by default, which grants them all the power and gives users no power, right? So today, there are IoT devices being introduced, such as the one that IoTeX has called UCAM, and services like NKN's Data Ride, and video content delivery networks that do protect user data and kind of put users top of mind, right? So I think this is a good segue into the last one around when shall we expect real Internet of Trusted Things products for our smart homes. So a shameless plug here, but IoTeX just launched this UCAM camera, which is a fully private home security camera that allows users to fully own their data. So we're starting to see the first wave of these types of products that use a lot of the fundamentals that we described today, and also put users first, right? So we partner with different enterprises that share the same vision as us, basically powering hardware devices with our software and firmware. But let me let Alan kind of close off today's session and just mention maybe how some of their solutions can be compared to traditional solutions, and why we should think about using these more protected products, and ultimately when we'll start to see things like this in our smart homes.
Yeah, and I completely agree with you. I mean, I think the things are swelling to the extent that people are understanding that having security in their home, also being able to protect their private data, is actually becoming more and more a thing, especially as we have these new vulnerabilities that come in. I think people are starting to be aware of the type of tools and capabilities that they can use to do that in terms of messaging and everything else. As far as NKN is concerned, you're right. The UCAM is a great example of that. For us, about the communications and really securing the communications layer, we've tried to provide security at the forefront or built into whatever products that we create at NKN. So for IoT, for instance, in our Data Ride product, we have that secure remote access. So a lot of times, being able to connect to your devices, regardless of where it is, have a end-to-end encrypted way to actually be able to communicate, get data from those devices is actually really important. And even the ability to actually do P2P or direct between a mobile device and the IoT device itself without having any third parties involved, I think also creates a much more secure environment. And it actually allows you to hold the data onto the devices that you have and not allow them to be used or distributed by those third parties, those tech giants that we talked about. So with that, I really appreciate everybody and some really great questions here for joining. And I'll hand it back over to Larry. Thank you so much.
Yeah, echo Alan's comments here. This is one of the very first webinars that IoTeX and NKN have embarked on. So it's really great to see the turnout and the engagement from the attendees regarding questions. So let me just close off by saying the risks to our smart homes and to our privacy. These things are much different than what's going on in the digital world, right? In the digital world, we have this concept of a safety net. For example, in the Equifax hack that leaked half the country's social security numbers, they had mechanisms to monitor your social security number for, things that may be out of place, right? And not to say that, it's not inconvenient, but the repercussions of the things we do in the digital world we can rein those back in, right? But when it comes to our physical devices, especially when we think about the future where, vehicles will be autonomous, a lot of the things we do will start to be automated, we really have to think, okay, if this process is being automated, what data am I providing to automate this process? And is it truly worth it, right? For example, if you only use your Amazon Alexa products to, instead of clicking into Spotify, you just want to say, hey, Alexa, skip track, right? Is that really worth it to have your Alexa device listening in your home 24/7? Or are there better ways to do it, right? So, it's important to think about the now apply those kind of recommendations to protect against those vulnerabilities that we talked about, but also, keep your eyes and ears plugged into the conversation regarding new types of devices that are built around privacy and security and convenience and user experience as well. So, with that, I really want to thank everyone for joining How to Protect Your Smart Home in 2020, and we hope to see you on future webinars. Thank you so much.